All right, 10 questions for the bell work right here. There we go. A lot of formulas right there, I know, but that's okay. Don't worry about this regular polygon business. You'll get into that later on. Let's see, is there any other unusual ones? No, it's all stuff that we've seen before. I guess, we haven't really looked at specific areas for formulas for square pyramids or triangular prisms kind of thing, but this would work. So all the main ones that we really need are on posters somewhere around the classroom, though. So here's our objective today. I can determine the two-dimensional shape a cross-section will make on any 3D object. Take 1 minute and copy that down, please. Now remember, two-dimensional objects are polygons, such as triangles, squares, rectangles, really any quadrilateral, but they're pentagons, hexagons, and so forth. Okay? We shouldn't see too much beyond a hexagon today, but we'll see. Circles as well would be two-dimensional shape. You're just looking at some kind of flat surface. But a three-dimensional object is like prisms we've seen, cylinders, pyramids, or cones. All right, and you get different shapes depending on how you cut these. When it says cross-section, that means we're going to take these shapes and cut them. And then we'll look at that and how that cut, or what type of shape that cut creates on the three-dimensional shape. So exploring polyhedrons, just a three-dimensional shape, pyramids, cones, and spheres. You'll need to describe each cross-section with a given plane for each shape listed below. So again, we're looking at what shape does the cut create. Again, cut, they're saying cross-section, which makes us sound smarter than we are. It's a very common thing in math. All right, so we're looking at cubes. We're going to start with cubes. And yeah, it's possible to do this with not cubes. You could use some kind of rectangular prism, but a cube is a nice way to look at this because you can manipulate it depending on what type of prism you're looking at, okay? But a cube, it's saying a cross-section of the cube to make a square. Well, the thing that we need to remember about cubes is that all of the lengths, all of the edges are the same length. So it's like a square that's three-dimensional. Boom, there it goes, cube. So like the depth is the same as the height, even though it may not look this way. I mean, we did the best we could. And then the width here, or the base value here, is the same as the height and the depth. Okay? Now we don't really need to find these values, like we're not going to measure these, but we just need to know that we're looking at a cube, all right? So when it says, hey, make a square, there's several different ways you can do that. And I guess for me, I'm gonna take my blade here, and I would take it, and then let's see if I can make this. Where I'm gonna slice it this way, and I would be aiming specifically for this part of the square. And so you can see, if I were to take this, it's just the edge of a blade. I don't want this to sound more violent than it needs to be, because I'm just chopping up a cube. Some of you guys are like, we want to see the blood. I'm not going to do it, all right, as much as I may want to. So I'm going to take this, and I'm just going to slice it straight down. And I know it's hard to say, well, I'm going to slice it diagonally, which, especially on a two-dimensional screen like this. But if you slice it straight down, you'd see that you'd be, let's assume that this is a straight line that I'm drawing, by the way. You'd slice it straight down, which would also make this other line. And then by the time you finished, assuming I'd drawn this better, you would end up with, well, a square, right? So I could say, look, we're going to take this and clean this up just a little bit. Well, you may think that's garbage, but I've done worse. So you can see the three-dimensional shape right here is a square now, specifically because it was cube on that. But again, even though I've sliced the cube, I don't care about the three-dimensional shape anymore. I'm just looking at the shape that was made from the cut. And so like if I take this and make it a stamp, for example, and I stamped it down, you would see a square. So I cut it this way to make a square. The other way to do this, let's see if I can make this shape. Oh, there we go. That seems okay. If I took the blade and I sliced it straight across like this, starting on this line, you'd end up with the same shape. So some of you may have said, I'm gonna take the blade and slice it down straight, and that'd be fine. Some of you said, I take it from either side and then slice it left or right. Doesn't matter. Well, you end up with a square cross section. It's important to make that distinction is we did make from this cut a rectangular prism, but the cross section is just the shape that was created, the two-dimensional shape that was created from the cut or the slice or the cross section. I feel like using slice is a little bit more applicable because some of you guys play some kind of like ninja slice game where you chop up fruit or something like that. At least that's what I've heard in the past anyways. So the shape that I'm interested in here is the shape from the cross section, the cut, which is the red shape. And that's a two-dimensional shape. It's just the surface that was made from the cut. And that's that red shape, the square, assuming I'd drawn that better. Not the three-dimensional resulting shape. Because you could say, well, which shape do you want as the three-dimensional shape? Well, is it this piece right here? Is it the piece that I sliced off and now is erased? Well, yeah, I'm just looking at the two-dimensional shape that was created, not the three-dimensional shape. The two-dimensional shape that's created actually is the same on both parts, right? So if I took, like I would say I took the back part of this shape, and then I'm looking at this this cross-section. But if you look at the other cross-section, like the part that I erased, the square would still be on the back side. So it should be the same shape. The two-dimensional shape should be the same on both. Now, I could create different shapes from the cross-section. Let me rephrase that. I could create two different three-dimensional shapes from a cross-section, even though the two-dimensional shape could be the same. On this shape, if I had cut it even further, like I say, I'd cut that pretty much in half right there. Like if I made like a really thin slice in the back, it would still be a square cross-section. All right, now we're still working with the cube. We're pretending like this is a cube, three-dimensional, and we feel like it's hopefully kind of inside that it's a three-dimensional shape. But we're going to make a rectangle, and there is a couple different ways to make rectangles out of this. What I'm going to do is I'm going to take this shape, and I'm going to take my blade and place it right, oh, that's a little big. I'm going to take it right and place it right at the edge here, the top, and I'm going to slice it diagonally to this edge right here, okay? Now what you see is that it creates kind of this three-dimensional shape, all right? But let's get rid of the other stuff so you can see that this would be a rectangle, and it's slanted, right? So it's definitely not a square anymore. But yeah, let's clean this up. All right, and then we get this I don't know if this makes it better, but oh, it doesn't. Okay, pretend like I didn't draw those lines, but that's a rectangle. Okay, if that was a stamp, the stamp would be a rectangle, as poorly as I drew that. But yeah, like if we were to take this and it was clay or something like that, you'd be like, well, I could slice that straight. Okay, if you can, then you'd have a rectangle. But even when I tried that, it's real wavy, and I just don't have steady hands, I guess. I'm gonna change the cut because you're right. I think I didn't go all the way through is what you're saying, and that's a good point. Okay, so let's start again. I'm gonna start this diagonal cut right here, but now I'm gonna go all the way to the very bottom part. That'll cut it all the way through. So now it's gonna be cut like this one, and again we're pretending like these are parallel cuts. I'll try to fix the iPad thing so it looks more parallel though. I don't know, something like this. And while that may look like it's a straight down cut, it's not. It's going from this edge or corner, I guess, to this corner right here. Yeah, I think this is better. So let me clean this up a little bit here. Get rid of this shape right here.
That makes more sense.
Thank you. Yeah, and now we get a trapezoid. Again, the red and the purple lines are parallel. And yes, staying within the lines is not my forte, but I watch plenty of Sesame Street. What about how do we make a pentagon? Oh, not too bad. Let's make a pentagon out of this thing. Yeah, while I'm slicing downwards, you may choose to slice sideways or upwards, or however you want to do it. But I always start at the top placing my blade. Yeah, for this cross-section stuff, we should only be making one direct cut. Yeah, and some of you see the cut that needs to be made on this one. Now, just because it shows up better, I mean, if I wanted to, I could start right here if I wanted to, but I'm not going to, okay? Because, again, I think it shows up better if I start by placing my blade along this line right here, okay? Now, just like we saw with the trapezoid, I'm going to slice this diagonally going downwards. But what I do want to do is when I end my cut, I want to be more towards this, well, we'll say this bottom corner down here, okay, like this one. And what's going to happen is as I slice downwards and diagonally, is that you would get this first cut right here between the two sides. And then those two cuts would continue from those corners down into this one. And then we see this five-sided shape, which is two-dimensional. But let me clean this up so we can see it a little better. All right, so this is now a five-sided figure. And yes, there was this green line right here, but it got messed up. Okay, but yeah, that is a pentagon. Is it a regular pentagon? No, it didn't say it needed to be regular. It just needed to be a pentagon, that's all. So let us make a hexagon from a slice as well, another cross section. Again, it should be just one direct cut. So again, I'm going to start diagonally like this. And what I would like to do is take this diagonal cut, and I just want to copy it. Okay, so I'm going to copy it down, but I'm going to slice it again. I'm going diagonally downwards. So these two green cuts, I have them the same just so hopefully it kind of demonstrates a little bit better. And I would take my blade at the top green line, and then I would slice it downwards diagonally, aiming for that other green line, which when I do, it creates first this shape, going down towards the corners, and then from those corners down to the green edges. And then we see, if I clean this up, that we end up with a hexagon now, six-sided figure. And you can keep those dashed lines there if you'd like, but yeah, we see a six-sided shape now. I'll try to color that in, and even though some of the lines are goner. Boom, there we go. Hexagon out of a one cross-section through a cube. All right, let's start making some cross-sections in a cylinder, but cross-section of the cylinder to make a circle. Now remember, from cylinders, the top and bottom, the bases are circles. So all I'm going to do is I'm going to take my blade and just slice it directly this way in half. Well, not really in half. It doesn't have to be in half. But when I do that, then I think we end up with, whoop, not a line. Let's see if this will work. I don't know, something like this. Boom. Okay. And yeah, cleaning this up, it would, for me, I would say I'd get rid of the top. And now this cross section, again, it's three-dimensional, so it looks like an oval. But if you replace it straight up, then you would see a circle such as this one. Okay? Same thing. Again, it's just three-dimensional. Yeah, that's how you would cross-section a cylinder to make a circle. All right, cross-section this cylinder to make an ellipse. An ellipse is an oval, for some of you that prefer to think of it as an oval, but whatever. In order to do this, because no matter how I cut it, usually I'll end up with a circle, but unless we cut it in more of a diagonal way, so I would place my blade right at the edge here, and then aim for just any other part of the diagonal of the other edge. So just not, as long as it's not a straight across cut. And so what happens from this one, let's see if I can demonstrate this okay, is, pretend like this is a good drawing, right?
Okay.
Like if I had an afro and I said that was a happy oval, you'd be like, hey, that's pretty cool. But as soon as I start teaching math, it's like, you freaking suck. All right, I don't know. I did the best that I could.
Didn't you used to have an afro?
I did, yeah. But it's too long to put into an afro now. So yeah, let me clean this up a little bit. Just make this look a little bit more pretty.
That one looks like a fruit ninja.
Yeah, right? Yeah. There's the oval, and again, this, if we were to look at it in its two-dimensional shape, would look more like this right here, which is an ellipse. All right, let's cut this to make a rectangle. Oh, this one's really hard. Yeah, no, I'm going to do it anyways. Now, I like to make this probably more complicated than it needs to be, but oh, not a circle. But I'm going to take my blade and place it along the edge of the top here. And all I'm going to do is cut it straight down. So that's going to give me these other two lines right here like this, which gives me this other edge right up and down. Okay? So cleaning this up is what we would end up with. The cross section, again, we're just looking at the cross section. But that is now a rectangle right up and down. So I tried to make it not look like hamburger. All right, let's cross section this cone to make a circle. No problem. That's all I'm going to do is I'm going to cut it because the base is a circle again. Let's see if I can fix this. I'm just going to take this and cut it once again just straight across like this. Okay, and so cleaning up this garbage, we end up with the circle. That's it. Right there. So cutting that cone, you can say in half. Just any straight horizontal cut along the surface here would give you a circle, differing in sizes, of course, depending on where you cut that. All right, cross section the cone to make an ellipse. Again, this is just all we need to make an ellipse is a diagonal cut, as long as it goes through any other part of the circle right here. So, well, again, whatever. I'm doing my best, but this would be an ellipse right there if we were to clean this up a little bit. Okay, something like that. There's an ellipse. Just cut it diagonally. How do we cut it to make a triangle? Oh, yeah, that's good. Yep, you'd have to go right through the tip right here. And then cutting it straight downwards, we'll say, not that one, but something like this would be created. And then you'd have the bottom right here, which would go straight through the edge. And yeah, that would be a triangle right there. All right, let me see if I can clean this up. That's pretty good. And we can see even the height would be kind of remaining right there because it was cut right through the middle. All right, cross section a sphere to make a circle. As it turns out, it doesn't matter where you cut this thing, it'll always be a circle. You're welcome to cut it. You could cut it diagonally. You could cut it straight and horizontally. You could cut it straight vertically, up or down. Doesn't matter. You could try to just kind of get the edge, but no matter how you do it, you're going to end up with. Yes, I'm sorry about my drawing, but it's a circle, okay? Now, of course, depending on where you cut it, you may end up with a bigger circle, like through the actual circumference of the sphere, but yeah, it depends on how big you want the circle to be. All right, let's cross section this pyramid to make a square. This is a square pyramid, by the way, so we know that the base is a square, which means all I need is just a direct horizontal slice on this. Which would make another square here, so something like this one. Boom. And again, we are pretending like I drew a square right there. There we go, there's a square. Let's go and slice this to make a rectangle, no problem.
Don't we just cut it diagonal?
Well, if you cut it diagonal, the problem with that is that you're going to end up with more of a trapezoid than a rectangle, right? In fact, well, let me see. That seems okay. I don't think that's what they're going for, but yeah, I'm trying to think. I would have to think about this a little bit more. I know I could make a triangle, right, just by cutting this edge right here. That's fine, but this isn't asking for a triangle. Yeah, so we'll say that, well, a square is just a very specific type of rectangle. So, okay, we'll just make the same cut and we end up with something like this one right here. Oh, that was bad. There we go, something like this. Yeah, just look at the bottom. I sliced the bottom very thinly. That sounds better. All right, what about a trapezoid? This is where we want that diagonal cut. So I would start here in the top, and I would start with my blade somewhere like this. And then I would cut it just diagonally anywhere else, and you'd end up with this type of trapezoid right there. Oh, there we go. There's our triangle cut. So yeah, I'm just gonna start here, and then I'll try to emphasize it a little bit. But if I cut this straight down, then I end up with that triangle right there. What about a pentagon? That's a 5-sided shape. So let's see. Oh, yep. Can I do that? Yes, I can. I'm gonna start here. I'm gonna start here in this top corner, and then I'm gonna aim for it to end along this line right here. Okay. So that would be a diagonal cut straight down. So that would start here, and then it would go straight down to here and here. Maybe that's not a great drawing. I'll just admit it's not a great drawing. But this is a trapezoid. I'm sorry, pentagon. It's a pentagon now. That's better. And some of you notice that with shapes like this one, right? Like in creating a five-sided figure, a pentagon, I had to go through 5 of the corners of the shape. Which is why we can't actually make a hexagon out of this. There's no way to go through 6 of the corners without just going through, I guess, another edge. But that's what we did on the cubes as well. When making a 6-sided figure, you got to make the cut go through 6 of the edges of that shape. Oh, that brings us to the objective. I can determine the 2-dimensional shape a cross-section will make on any 3D object. Well, just at least a few of them.